Welcome to another Mr. Paul video. Today we're discussing comparing functions. Comparing functions, that means we're going to have a function and we're going to compare it to another function. So let's just imagine y equals mx plus b is going to be the generic function that we have. But if we're going to compare two of them, we're going to say that we need another one, y equals mx plus b. As you can see, that's going to get very confusing very quick because when we say, hey, that m, we're like, oh, that m or this m. Oh, wait, we're talking about the b, but are we talking about this b or this b? So the way that math solved it is by giving these things names, giving these functions names, okay? This is the first way we're going to introduce what's called function notation. And I want you to think of this as a way to give functions names. Way to give functions names, okay? And the popular names that they choose are not like Mark, they're not Sally, they're not Najib, they're not Jesus, they're not any of those, okay? They choose boring names. They choose math boring names. They choose something like f of x, g of x, and h of x. So these are going to be the names of the functions. And what they're going to do is they're going to replace the y in each of these equations. So an example for this first equation might look like f of x equals mx plus b. And the example of this second one, they won't choose f because that would be like giving it the same name. So maybe they'll use g. So g of x equals mx plus b. So f and g are just the names of the functions, okay? And where they decide to put it is they replace the y. Now, I don't want you to think that all of the rules are gone. The exact opposite. Everything that we knew about y equals mx plus b is still true here. I still know what the slope is. I still know what the y-intercept is. The only difference is that instead of y, that's where they put their name. I still know where the m is. I still know where the b is. They just replace the y with its name. So, for example, when I'm starting to compare functions, let's just say f was something along the lines of f of x equals 3/4 x plus 1. And we'll say that g of x equals 1/2 x minus 3. So if my question is something along the lines of which function has the lower y-intercept, you can quickly identify, well, what is the y-intercept for the green function, meaning the function named f, or the blue function named g. So if we're looking over at f, we can use our y equals mx plus b understanding and say that our b is equal to 1. We can use our y equals mx plus b to understand that our b is -3. So when we're asking which function has the lower y-intercept, obviously -3 is lower than -1, so we say that g of x is our correct answer. When comparing functions, we have to understand that we have to give them names so that we can decipher which one's which. Could you imagine two lines on the same graph? It would be crazy. Math crazy, not real crazy, math crazy. We wouldn't be able to tell what's what. On a paper, it's a little bit easier to see if we use colors, but this is the way math decides to label it. So let's do a couple more examples. I'm going to get rid of this function notation stuff. Actually, let me leave that top part here. Let me leave the top part. Suppose I want to compare two functions. F, which is the name of my first function, is going to be 5x plus 2. And then I'm going to name my second function g of x. Remember, these are just names, right? They're just names. Don't get confused. This is still y equals mx plus b, and this is just replacing the y. I have a table this time. Let me erase this. X, g of x. Zero, -3. 1, 2, 3, -1, 1, and 3. Okay. So remember, this is just like a table where this was x and this was y. But we're placing the y with its name. Okay, this is still the same table that we know and love. So the question is, which function has the larger slope? Which function has the larger slope? And the choices are f, what's the slope here, and g, what's the slope here? Well, let's use our knowledge of how do you find slopes with the equation. Well, we're looking at this 5, right? This is m. And then when we're looking at this one, where the slopes are the change in y over the change in x. But the x's are up here and the y's are down here. But Mr. Paul, I don't see a y. Remember, you could treat this just like y. All they did was replace the g of x, or replace the y with g of x. But the rules still apply on how to find slopes. So my x's are changing by 1. My y's are changing by 2. So which one of these has the bigger slope? Pause the video. Pause the video, see if you can figure it out. Let's check it out. This first function, remember, y equals mx plus b, where m is the slope. So this has a slope of 5. This table is the change in y over the change in x. Well, the change in y is going up by 2. The change in x is going up by 1. So which one's greater, 5 or 2? Our answer is f of x. Remember, f of x is the name. Do we have to name the entire function? No, just f. It's like saying its name. Okay, one more example. Suppose we have a function, f of x, and it looks like f of x is equal to it's a table. Sorry, I have to take my notes. X and f of x (0, 3, 1, -1, 2, and 1. And then I have a graph that looks something like this. And then let's just say the line going this direction represents g of x. Let's say it's a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and my question to you is, which function has the lower intercept, y-intercept? Which function has the lower y-intercept? I encourage you to pause this video and see if you can figure out which of these two has the lower y-intercept. Well, let's take a look at it. I have a function here, and I'm looking for the y-intercept, meaning I'm looking for b equals or 0, b. Remember, in tables, we're looking at this. So my y-intercept for this table is b is equal to 3 because 0, 3. Well, in this graph here, I know that it crosses the y-intercept at -1, so this b is equal to -1. So when the question asks, which function has the lower y-intercept? -1 or 3? G of x is lower, so the answer is g of x. I know function notation is very strange. I know it is. But I want you to understand that all of the rules, all of the different techniques that we've learned up until now are still true. Everything still works the exact same way. The only difference is they replace y with a name. That's the only difference. The names look funky, right? They don't say Steve, Mary. They don't say Jesus. They don't say that. They say f of x, g of x, and h of x. Strange names. That's all for today's video. Hope it helps. Peace.